Hi, my name is Divesh and today I'm going to talk about satellites. First up, what is a satellite? In context of spaceflight, a satellite is an object that has been intentionally placed into orbit. Satellites are placed into orbit to circulate around the Earth. There are two kinds of satellites which can be broken down into natural satellites and artificial satellites. These objects are called artificial satellites to distinguish them from natural satellites such as the Earth's moon. On 4th October 1957, Russia launched the first ever satellite into space 60 years ago. Sputnik 1 was the first man-made object to leave Earth's atmosphere. The launch of Sputnik 1 marked the dawn of the space age. This began the space race between America and Soviet Union. The 184-pound satellite orbited Earth and sent back radio signals. The metal sphere completed 1,440 orbits over its 21-day mission. Since then, about 8,900 satellites from more than 40 countries have been launched. According to a 2018 estimate, around 5,000 of them remain in the orbit. Of those, about 1,900 were operational, while the rest have lived out their useful lives and become space debris. Approximately 63% of the operational satellites are in low Earth orbit, 6% are in medium Earth orbit at about 20,000 kilometers up high, and 29% of them are in geostationary orbits at about 36,000 kilometers up high. Right now, there are nearly 6,000 satellites circling our tiny planet. About 60% of those are defunct satellites, which are space junks, and roughly 40% are operational. The Union of Concerned Scientists (UCS) determined that 2,666 operational satellites circled the globe in April of 2020. Over the coming decade, it's estimated by the Euroconsult that 990 satellites will be launched every single year. This means by the year of 2028, there could be about 15,000 satellites orbiting the Earth. Moving on to the types of satellites. First up, we have geostationary satellites. A geostationary satellite is an Earth-orbiting satellite placed at an altitude of approximately 35,800 kilometers directly over the equator. This revolves in the same direction the Earth rotates. At this altitude, one orbit takes about 24 hours, the same length of time as the Earth requires to rotate once on its axis. The term geostationary comes from the fact that such a satellite appears nearly stationary in the sky as seen by a ground-based observer. BGAN, the new global communication network, uses geostationary satellites for its operations. Next, we have non-geostationary satellites. A non-geostationary satellite has an orbital period which is not equal to the orbital period of the Earth. It has a lower orbit, hence it can take more detailed pictures. It's suitable for mapping and spying. This satellite is situated at any point above the Earth for only a short duration of time. The launch that takes place over the orbit is cheaper than launching a geostationary satellite to a higher orbit. The average lifespan for a non-geostationary satellite is about 5 years. Let's look at the advantages of satellites. It is used for mobile and wireless communication applications independent of location. It covers a wide area of Earth, hence entire country or region can be covered with just one. It is also used for voice, data, video, and any other information transmission. Satellite systems can be interfaced with internet infrastructure to obtain internet service. It is also used for GPS applications in various mobile devices for location determination. It is used in wide variety of applications which include weather forecasting, radio or TV signal broadcasting, gathering intelligence in military, navigation of ships and aircrafts, global mobile communication, and connecting remote areas. Every advantage has its disadvantages. So now we'll look at the disadvantages of satellites. First up, satellite manufacturing requires more time. Moreover, satellite design and development requires higher cost. Satellite once launched requires to be monitored and controlled on regular periods so that it remains in the orbit. Besides, its redundant components are used in the network design. This will incur more cost in the installation phase. Next, I'm going to talk about the physics laws involved in gravitation. Firstly, we have gravitational force. Newton's universal law of gravitation states that the gravitational force is proportional to the product of mass of two bodies and inversely proportional to the square of distance between the two bodies, in which F equals g m1 m2 over d2, where F is the gravitational force between two bodies, m1 the mass of first body, m2 the mass of second body, d the distance between the center of first body and second body, and g the universal gravitational constant. Next, look at centripetal force. Although the object moves in a circle at uniform linear speed, its direction is constantly changing, whereas the magnitude of its velocity is constant. The object experiences acceleration in the direction of the center of the Earth due to the change in velocity. This acceleration is known as centripetal acceleration. Centripetal acceleration is given by A equals v2 over r, where v is the linear speed and r is the radius of the orbit. Since the centripetal acceleration is always directed towards the center of Earth, there is a force acting on the object and is directed towards the center of Earth. This force is known as the centripetal force. The centripetal force goes by the formula of F equals to ma. As we all know, A is equivalent to v squared over r. This leads to the formula of centripetal force as F equals to mv squared over r. Next, we have Kepler's law. Kepler's law can be divided into three. Firstly, we have Kepler's first law. Kepler's first law states that all planets move in elliptical orbits with the Sun at focus. A circle only has one focus, whereas an ellipse has two focuses. This is so that from any point of the ellipse, the sum of the distance to the two focuses, L1 plus L2, is the same. In the orbit, the major axis is longer than the minor axis. Most orbits of the planet in the solar system have major axes and minor axes of almost the same length. As such as the shape of the elliptical orbit of the planets in the solar system is almost round. Planets can be assumed to make circular motions around the Sun. Moving on to Kepler's second law. This law states that all line that connects a planet to the Sun sweeps out equal areas in equal times. The area A is constant even though the radius and curvature will change. According to Kepler, if two areas is the same, the time taken to move from both areas is almost the same. The planet's speed must vary in order for the time to remain constant. The planets move faster when they are closer to the Sun. Last but not least, we have Kepler's third law. This law states that the square of the orbital period of any planet is directly proportional to the cube of the radius of its orbit. A planet which has a larger radius has a longer orbital period. The further the Sun from the planet, the longer it takes to complete one round of the orbit around the Sun. To sum everything up, Kepler's third law can be formulated using Newton's universal law of gravitation and concept of circular. The centripetal force is the same as the gravitational force between the Sun and the planet. Therefore, centripetal force is equivalent to the gravitational force. This is my satellite model. The blue panel is a solar panel which converts sunlight into energy to power up the satellite.